Selling behind the counter. Then on the macho like Randy. The chopper go out to the granny. This nigga pull up your bandit. The killers understand it.
Hello everyone, this is Kiran, Director Skilltronics Technologies Private Limited. In this video, we are going to learn about 3 variable K-maps. Here you can see the rules to be followed for using K-maps, and shown below is the truth table representation of any Boolean function. So now let's go with the example 1. F of a comma b comma c, 3 input variables, is equal to summation of small m of 0 comma 1 comma 3 comma 5. Here in this Boolean function, in this canonical Boolean function, you are having 4 minterms. It means m0 plus m1 plus m3 plus m5. So this canonical Boolean function can be expressed like this, and the meaning of this expression is every minterm present in this function is carrying a value 1. So mapping this function in the truth table will be like this. M0 means, as M0 is present there, you'll have 1 here. M1 is also present, so in the output column you should write 1. M3 is 1 and M5 is 1. So out of the 8 possible minterms for a 3 variable function, 4 minterms are carrying output values 1s. It means that the remaining values are zeros. But we do represent only the 1s in the K-map. So already the minterm numberings were assigned to every square present here, and as this is a 3 variable K-map, we require 8 squares according to this formula of 2 power n, where n is the number of input variables, and in this case n is equal to 3, so 2 power 3 is equal to 8, and 8 is the number of squares for our K-map. So 4 minterms, I am mapping the minterms now, m0, m1, m3 and m5. Now we are having 4 ones. According to the concept of grouping of K-map, you can form one group for 4 minterms, but these 4 minterms must be adjacent to each other. But in this case, all these 4 are not adjacent to each other. So if you see, these 2 are adjacent, these 2 minterms are adjacent, and these 2 are adjacent. It means that we have to form a minimum of 3 groups of size 2. So this is a pair with which we can accommodate 2 minterms in this pair, and here this is another vertical pair which accommodates the additional minterm number 5, and here the third pair. So this is number 1, number 2 and number 3. So the result of first pair is A dash, and at the top, if you can see, B dash and C dash for M0, B dash and C for M1. So out of these 2 variables, for these 2 minterms, B dash is not changing, whereas variable B is not changing, whereas C is changing. So we have to neglect the changing variable and select the unchanging variable. So the result includes B dash. Now for the vertical pair, A is changing, whereas B dash C is same for both the minterms. So the result of this pair is B dash C, and for this pair of M1 and M3, the common variables are, here as it is a horizontal pair, A dash will be there for sure, and vertical side we are having B dash C and BC. The unchanged variable is C, so C gets qualified. So these are the product terms which are the resultant of drawing 3 variable K-map. So the result of this function is f is equal to a dash b dash, that is the result of group 1 plus result of group 2 plus result of group 3. So f is equal to a dash b dash plus result of group 2, that is b dash c, plus result of group 3, that is a dash c. So this is your minimized function. Now let us have a look at another example of a 3 variable K map or a 3 input variable Boolean function f of a comma b comma c is equal to summation of small m of 2 comma 4 comma 6 comma 7. Let us map the minterms first. 2, 4, 6 and 7. Again, this K map is having 4 minterms, but unfortunately these 4 minterms are not adjacent to each other. So one thing what we can do is, we cannot form here a quad, rather we can form the lower size groups called pairs. But how many pairs we need to form? That is, let us see. These two ones are adjacent to each other, so we can assume that we can form a pair here, and these two are adjacent, so we can form a pair here. And after forming two pairs, one for the vertical and one for the horizontal, another minterm is being left. So this one need not be left alone, because if you fold this K map by bending it at the exact half, this minterm number 4 overlaps minterm number 6. It means that M4 and M6, or the squares 4 and 6, are adjacent to each other. And as these two adjacent squares are carrying 1s, you can form a pair for these two squares. So let us see forming of groups and their results one by one. Here you can form a vertical pair. Let us write the result of this first. This is a changing variable, so we should neglect it, and the unchanging variables are b and c dash. The next one, this is the next pair, and the result of this is, as this is a horizontal pair, there will be one variable from the horizontal side, and from the vertical side the unchanged variable is b, so b gets qualified. After these two, another minterm is left. As we already discussed, we should form a pair like this. If you observe, I have kept something open here and here also. It means that when you are standing here, this open group indicates that there is some minterm on the other side of the map which is ready to get paired, and if you stand here, the same will be intimated to you. So while forming edge or corner quads, it is always preferable to make this pair or make this group open on one side. So the result of these two minterms which are forming a pair is, as this is a horizontal pair, again A gets qualified, and on the vertical side, here you are having b dash c dash, here you are having b c dash. So the common variable is c dash. So the result carries c dash. So the overall result for this function is f is equal to group 1, that is bc dash, plus group 2, that is ab, plus group 3, that is ac dash. So this is about K-maps. For the canonical Boolean functions, we performed simplification or minimization of Boolean functions using K-maps. Now, a new concept in the K-maps or minimization procedure is that apart from your regular minterms, you will have a separate type of minterms that are called don't care minterms. don't care. The term itself denotes that you need not bother about that minterm. So this function, I'm taking the same example of 0, 1, 3, 5 for explaining the don't care problem also. So apart from these minterms, I have added two more minterms called don't care minterms. So if this is my canonical Boolean function, first of all let us see how we have to denote this in our truth table. So earlier our function is carrying four minterms 0, 1, 3, 5, and now you are having two don't care minterms. Those are M2 and M6. So at the place of M2, instead of writing 0, you should write a don't care, and don't care is always represented with a cross mark, and M6 also should be represented with a cross mark. This is a truth table representation of the given canonical Boolean function with don't care minterms. Now let us see how to map these minterms here. As we already learned that minterms carrying ones only will be mapped in the K-maps, and the minterms carrying zeros will not be mapped. So here there will be a controversy that if we map the minterms carrying ones and if we leave the minterms carrying zeros from the K-map, then what we have to do for the don't care minterms? We should represent don't care minterm with a cross mark even in the square assigned to it. You cannot simply leave the don't care minterms from mapping in the K-map, because if you leave those K-maps, those will be treated as minterms carrying zeros, and if you represent these don't care minterms with ones in the K-map, it will be treated as minterms with values ones. So both are not correct. So the best method is to map these don't care minterms in the K-map with a don't care mark. So 0, 1, 3, 5, and the don't care minterms here are 2 and 6. So this is what I have to place. After mapping this, here the don't care symbol X means you can consider either a 1 or a 0 according to your necessity. And how this necessity will be understood? In this particular example, you are having 3 ones here, and in order to form a larger size group in the terms of powers of 2, it is 2 power 2, that is 4. That means if you are having 4 ones in a sequence, you can form a horizontal quad in this particular example. So if instead of this X, if we have 1, we can form a horizontal quad. But unfortunately, this is not 1, this is X. That means it can also hold a value 0. Similarly, the same is the case for the second X. So we have to make an examination that which value suits this don't care in the particular example. So here, if I consider this don't care as 0, I cannot form a quad. But according to the rules for the K-map, it is always preferable to form a bigger size group. So if I assume this don't care to be 1, I can form a quad. So I prefer this don't care to be carrying a value 1. So I am forming a group here, and this is a quad consisting of 4 minterms. Means this X is now denoting minterm value 1. After grouping this, we are left out with a minterm with value 1 and a don't care minterm also. People generally do mistakes at this stage that they feel like they have to group each and every minterm. According to the rules of the K-map, while we perform grouping, we should not leave any minterm ungrouped. So according to that principle, as we are having 2 minterms here left out, and these two are even not adjacent to each other. So we need not consider these to be inams because this one is having some adjacent minterm to this. Of course, this don't care is also having an adjacent term, so we can perform pairs. We can form pairs. These two ones can be kept in a pair, and if you see this don't care, this is the only minterm left out in this example unpaired, and the name itself implies don't care. So you are left out only with one don't care, ungrouped. You need not bother about that. So you need not form another group in order to include this don't care minterm. So please don't try to form an extra group, an additional group to make this don't care minterm being a part of that. So you can simply neglect this because we are assuming that this don't care is having a value 0. If you assume this to be 1, we need to pair it. But in this case, this don't care is not helping us to simplify our Boolean function. So you can simply neglect this by assuming that this don't care is carrying 0. So let us write the resultant of these groups. Quad means for all the 4 minterms, the common variable is a dash, so this qualifies, and at the top, if you see, for all the 4 minterms, both b and c variables are keep on changing. Here you are having b dash, here you are having b dash, but here this is b, this is b. 2 variables, for 2 minterms, b is unchanged, for 2 variables, b is unchanged. In the same way, the c. That means none of the input variables are getting qualified because you are forming a single group, and for a single group all the variables are changing from one minterm to other minterm. So the only variable that gets selected, that gets qualified for the output is a dash, as this is a horizontal quad. And coming to this pair, the result of this pair will be in the horizontal side a is changing, so you should neglect this. On the vertical side, for these 2 minterms, the common variables are b dash, c. So these are the resultants of the 2 groups formed. So the final answer is f is equal to a dash plus b dash c. Now let us see the same second example with some don't care minterms, so that you can have a better idea of how we can use the don't care minterms. 2, 4, 6, 7. And the 2 don't care minterms are 1 and 5. 1 here and 5 here. So if you observe the previous example, this is looking something like a mirror image of the example number 3. Again, if you assume this don't care to be 1, it helps us in forming a bigger size group called quad, and this don't care is of no use for us in any way. So we have to assume that this value is 0. This is a quad, and this is a pair. The result of this quad is a here. Only a will be qualified because all the 2 variables at the top for each minterm are keep on changing. And the result of this pair will be a is changing, so a cannot be selected, and at the top, as this is a vertical pair, the 2 variables at the top will be qualified, b, c dash. So that the answer for this problem is quad, result of quad a plus result of pair, that is b, c dash. In the next video, we are going to see the 4 variable K-maps and some examples on 4 variable K-maps. Thank you.